All right. Now, you guys too. You're going to be my assembly line. All right. Here's what their job is. We're going to talk about We're talking about reactions here and how they happen. What's called the mechanism by which they happen. I'm going to have them make a little widget. Okay. I'm going to call it a widget. I'm going to take a black, white, blue ball, put them all together, and make this guy right here. So when they're done on their assembly line, okay, when they're done, they're going to have this. This is what they're going to make. All right? Each guy's got a job on the assembly line. Whoever's standing here is going to put this one together, put that on, put that on. Now you're all going to work as fast as you can. You get yours done before him, put it down, he'll pick it up. If you get yours done before him, put it down, he'll pick it up. Okay? And we're going to watch what happens. Now I want you to watch carefully what happens as they do this. Okay? Let me make sure everything's in pretty much stand in front of your thing there.
You're going all the way down. I'll get the one on the end.
Yeah, it looks like that's pretty good. All right, you ready?
What the hell are we doing?
On your mark. Hey, the bell didn't ring. You are in a factory. You're working in a factory, and they didn't ring the bell yet. Wait, I'm gonna ring the bell. Wait.
Child labor.
Go.
That was the crappiest bell ever.
Come on. Fast as you can. Put them together. We're moving along. Put it together. Put it down. Put it down. Hold it. Come on. Put it down. Put it together. Put it down. Now you watch what happens. Only one goes on. Only one.
Jack wagon.
Holden, you're ruining it.
Come on. Y'all watching? There's something's happening here. What are you doing? Aside from the fact that. Here you go. Wow. This is not good.
Holden's going hard.
Holden is not holding us up. Woo! Who's holding us up here? Hey, you're holding us up.
I know what you're feeling.
I can't get it in.
Let's go, Jake.
I'm getting paid overtime.
Yeah. Notice the lack of effort by Holden.
Holden's done.
I know.
Yeah,
Notice how hard Dayton's working. I did not put Dayton in this position. He chose that.
I ain't messing around.
Notice that Bulkley's waiting around most of the time, right? So what's the deal
The
here?
middle step.
Exactly. The middle step's the slow step, isn't it? I did that on purpose. Yeah, he did.
I was the middle step when I moved over.
Now, while they're still standing there, let me explain something. Let's say I'm at the other end of the factory assembly line. I'm the foreman. I can't see them working, but I notice that they're not coming out fast enough. So I say, okay, well, maybe the trouble is Holden. I'm going to give him a helper today. I give him a helper. Are we going to make them any faster?
No.
So if I give a helper to Bulkley? No.
No.
But if I give a helper to Dayton, things are going to go twice as fast, aren't they?
Yes.
Twice as fast, because he'll be doing that job twice as fast. All right, have a seat. So as you can see, hi, Mom.
Balls.
I guess we're using the other one. Hit that light for me, please.
Oh, Bulkley, you're ruined.
I wheel this back up.
Oh yeah. Just hand me that whole thing, and you can just push that over to the side somewhere. All right. So let's go back and explain that. What happened? Ready? All right. This is what we call same thing that happened in organic. No, don't worry. You're not copying this. You're not copying it. It's the same thing that happened in organic when we had mechanisms. And now it will make a little bit more sense. Why did we call the SN1 mechanism, which had 2 steps, and this guy was called the SN2 mechanism and only had 1 step? This is why. Turns out, in the SN1 mechanism, only one guy, in this case it was Dayton, even though there were 2 chemicals involved, water and the alkane with the bromine on it. There are 2 chemicals you added together, but only one of them controlled the entire rate of the reaction. And now you know why. Because that's the slow step. That carbon losing his bromine in the first step. And then the second step being the OH attaching really, really fast because you've got a carbonium ion there with a charge on it. It's going to attract that guy. All right. This slow step is what controlled everything. Just like Dayton controlled everything. If I gave Dayton a helper, we would have got stuff twice as fast. And it wasn't just as bad as this. In reality, in a chemical reaction, Dayton wouldn't just be a little bit slower than the other two guys on your side of him. He'd be 1,000 times or more slower. So, like, it makes no difference how much really Bulkley I have or how much Holden I have. And that makes no difference. All right? As long as somebody, now, it does make a little bit of a difference. If I were to hit Bulkley over the head like I am often tempted to do and knock him out. So, in other words, if I take Bulkley out of the equation, would I get any widgets coming down the line? No, he has to be there in some capacity, but as long as he's making them, all right, Holden or Dayton's so much slower, that middle step is so much slower, that's what controls the entire rate of the reaction.
That's why he keeps me around.
See that? And this guy, both of them were involved in the same step. It was only one step, so that's why it was SN2. Two guys are involved. And here's what that means. Increasing the concentration of water in this guy, who's not involved in the slow step, is like giving a helper to Holden or Bulkley. Doesn't do anything to the reaction. Giving a helper to either of these guys, in other words, increasing the concentration of water or the alkane in this case, either one of them increases the rate, all right? Because they're both involved in the slow step, whereas that guy only hit once. All right, you understand? Kind of gone back to do it. Now we got to talk about all of this, put it all together into your notes, and try to quantify it. That's going to be the real tough job, quantifying all this.
It's a big word.
In other words, we're going to be able to, by the time I'm done with this period, I'm actually not this period because I told you I'm just starting it today. But by the time I'm done with next period, tomorrow, when you have a double, you're going to be able to put numbers to these mechanisms, okay, as well. But for right now, let me just kind of summarize what you've just seen. A mechanism, first of all, is the series of steps that are involved in a chemical reaction. Just like an assembly line, okay? It's a series of steps you have to go through. We've kind of seen that before with the mechanisms we saw with free radical halogenation, electrophilic addition, nucleophilic substitution. They all had multiple steps. But don't worry, we're not going back to organic. We're just going to be dealing with it on a mechanical or on a numerical level. All right, so that's what a reaction mechanism is. Now, what you notice in a mechanism example like I just showed you is you have something called a rate determining step. That rate determining step was Dayton. He is the slow step. And he alone determines the overall rate of the reaction. Now, I will start at this point tomorrow, all right, reminding you of this, and then going from here. I won't have to do the demo. I won't have to give you these little bit of notes, and that way you'll have time to actually get through this in one period when I'm about to show you the actual math and numbers that are involved. But I'm going to stop it right here, all right, because